today we'll continue to talk about data structures. So we'll talk about another type of data structure that is stack today. And so first, what is a stack? A stack is a linear data structure in which the insertion of a new element and removal of an existing element takes place at the same and represented as the top of the stack. So to implement the stack, it is required to maintain the pointer to the top of the stack, which is the last element to be inserted, because we can access the elements only on the top of the stack. So there is a very important concept related to stack, that is LIFO, which is last in, first out. So this is a strategy states that the elements that is inserted last will come out first. You can take a pile of plates kept on top of each other as a real-life example. The plate which we put last is on the top, and since we remove the plate that is at the top, we can say that the plate that was put last comes out first. So here we'll talk about two different types of stacks. So the first one is called fixed size stack. So as the name suggests, a fixed size stack has a fixed size and cannot grow or shrink dynamically. If the stack is full and an attempt is made to add an element to it, an overflow error occurs. So if the stack is empty and an attempt is made to remove an element from it, an underflow error occurs. So the other type of stack is called dynamic size stack. A dynamic size stack can grow or shrink dynamically. When the stack is full, it automatically increases its size to accommodate to the new element. And when the stack is empty, it decreases its size. So this type of stack is implemented using a linked list, as it allows for easy resizing of the stack. So here we will talk about some basic operations on the stack. So the first one is push. So it is used to insert an element into the stack. And the next one is called pop. It is used to remove an element from the stack. So a moment before we talked about LIFO, so we can illustrate it here. So we have a stack here, and if we want to push an item to it, so we can see that the top of the stack is here. So the item will be placed on the top, so it is here. So it becomes the new top of the stack. So if we want to pop an item from the stack, the stack will pop or remove the first item of the stack, because it is the last one to come into the stack. So the element at the top of the stack will be removed when you pop. And another operation called top returns the top element of the stack, and the operation is empty returns true if the stack is empty, and if the stack is not empty, it will return false. And the size operation returns the size of the stack. Okay. So now we will talk about the linked list implementation of the stack. So for the linked list implementation, the advantages are the linked list implementation of a stack can grow and shrink according to the needs at runtime. And it is used in many virtual machines like JVM. So the disadvantage is that it requires extra memory due to the involvement of pointers, and the random accessing is not possible in a stack. And these are also the same disadvantages of the linked list compared to arrays. And so we'll give you an example of a implementation of stack using linked list. So here you can see is a public class called stack as linked list. So inside this class, we will use linked list to implement a stack. So first we have a stack node called root, and then we have a static class called stack node. So here the implementation is like the implementation of linked list we talked about last time. And now after this, we have some methods to implement the stack. So these methods are the key that we know this class or this data structure is, for example, different from linked list. So now we first see the push method. So if we want to push a, for example, in-type data into the stack, we will just add it to the stack, and then we change the root or aka the top of the stack to this new node. So the push operation is the operation we talked about last time to add an element to the front of the linked list. Okay. So similarly, the pop operation is deleting the first element of the linked list, and we will just remove this element and change the reference of the root, and then the element is removed from the stack. Okay. So here we have a few codes to test our implemented stack. So if we create a new stack here and we push 10, 20, and 30, and then we print them out, when after we pop them, we will see the results. Okay, so we can see that after we push 10, 20, and 30 into the stack, and after we do an operation of pop, 30 is popped from the stack. It is removed because it is the last one to get into the stack. And now after removing 30, its current top is 20 because it is the second last one to get into the stack. Okay. Now, after talking about how to implement a stack type data structure, now we will talk about how you will create a stack in Java. So you can see that this code is how you will create a stack. So inside this place of E, you will put the type of data stored in the stack. For example, if you want a int type stack, you will type integer here. And here is a code to test a implemented or created stack in Java. So here are some written methods to, for example, push the data into the stack or pop. And we can see that we just create a new stack in this form, and we want its inside storage type to be integers. And then after doing this series of operations, we first push, use the method stack push. So this method will push the type will push the integers from 0 to 4. And now we can see that the next operation is stack pop. So this method will pop is storage inside storage, and it will do this stack.pop operation 5 times. So we can see the result is that it popped 4, 3, 2, 1, and 0, because the order that you push into the stack is 0, 1, 2, 3, and 4. Okay. So now we will talk about some application of the stack. So backtracking is one of the algorithm designing techniques. Some examples of backtracking are the knight tour problem and queen problem, find your way through a maze, and game like chess or checkers. In all these problems, we dive into some way. If that way is not efficient, we come back to the previous state and go into some another path. So to get back from a current state, we need to store the previous state for that purpose, and for this operation, we will need a stack to implement this. And in memory management, any modern computer uses a stack as the primary management for a running purpose. Each program that is running in a computer system has its own memory allocations. String reversal is also another application of the stack. Here, one by one, each character gets inserted into the stack. So the first character of the string is on the bottom of the stack, and the last element of the string is on the top of a stack. So after performing the pop operations on the stack, you get a string in reverse order. So this is a very useful technique. So we'll give you an example. For example, if we have a string called Tony, okay, and we want to reverse it, so the actual result should be YNOT, right? So we first create a stack like this, and then we push the each characters of this string into the stack. So it should be T, O, N, and Y. Then we pop each of the elements out of the stack. So it will be Y, N, O, and T. And this string will be successfully reversed. And stack also helps in implementing function call in computers. The last call function is always completed first. And stacks are also used to implement the undo-redo operation in text editor. So now we have talked about all the aspects that is commonly used or of the data structure stack. So we have limited time today, so we are not able to talk about Q, and so we will talk about Q next time. So that's all for today's club activity. So thank you.